Hello and welcome back to another special episode of Josh's Engine Rehab. Today, we are finally going to talk about this thing I've been gaslighting you about for the past, 3 months. We're going to work on Porsches. Finally, Porsches! And not just any Porsches, these are air-cooled 911 heads. And now, I'm not being judgy, I'm not being a snob. I'm gonna bet you guys don't exactly know about the weird little intricacies about how these things go together. They've got some interesting design choices. I mean, the Germans, they're very particular about the way the engines go together and their design and whatnot. But let's get to the point. These don't have head gaskets. In fact, there's nothing that goes in between the head and the cylinders. And really, they're just relying on a precision fit between the cylinders and the sealing surface. And they went through a few different iterations of how these cylinders went together. In fact, this cup holder, well, not cup holder, pencil holder, world's most expensive pencil holder is, let's see, come on, is the result of a mistake I made. This goes to one of these cylinder heads. It's like an early 911. But these did have something that worked as a sealing ring or a head gasket of sorts. It's just an annealed steel or a soft ring that goes inside of this groove. Like that, and then it would that ring would put positive pressure on the sealing surface. Really, it was an imperfect system. It didn't work all that great. But later on, we switched to a flat surface on the top of the cylinder that just mated to another flat surface, just like that. And this surface, it tapers up about 2 thousandths to the inside of the cylinder. So really, when these things get clamped together, the inside of this bore kind of bites into the cylinder head, and that's really how they seal. And these things don't even get held together with that much clamping force. I mean, these two little tiny 10 millimeter or 11 millimeter studs, they torque to like 45 foot-pounds or something minuscule like that, but they work. They work pretty well. Another weird design decision that was made by Porsche very early on was they don't use steel cylinders or sleeves in their air-cooled engines. This is just an aluminum or a cast aluminum cylinder with a Nikasil plated bore. So they aren't serviceable. I mean, if your cylinders are worn out, you're not going to get to bore it oversized. You're going to either have it replated or just buy a new set of cylinders. And that's basically what most people do, to the tune of about $1,000 a piece. That's just one of those things. Porsches can be a little bit cost prohibitive, but Nikasil plated cylinders, they are pretty tough. They have their issues. They're pretty sensitive to overheating, maybe even to lack of lubrication. So if you had an engine problem, there's a good chance that you probably damage your cylinders too. But I mean, if your engine was just worn out and your rings were worn out, you pull it apart and your cylinder bores had a reasonable amount of wear, you could re-ring them theoretically, but most people don't do that considering how much time it takes to disassemble and reassemble a 911 engine. Now these engines, they're horizontally opposed. It's a flat six. So just imagine you've got your regular old six cylinder, so like a V6 or whatever, but instead of the cylinders being laid out in a V, they run opposed to each other. So you'll have a bank of 3 cylinders running to the left, and then a bank of 3 cylinders that are going to be pointed to the right. That's very cool. It's very good for packaging. The cars have a very low center of gravity, but another thing is the engines are inherently balanced. And another thing, I'd say this is a lot more important, they make a very, very compelling noise. And as far as assembly is concerned, they're Legos. Really, once you understand the way that they go together. Now let's talk about that. Now it shouldn't surprise anyone when I say that precision is the name of the game with a Porsche engine. I mean, it's like that with any engine, but more so with these because there's a few more intricacies that are involved with specifically these engines. And it's kind of like a VW, but it's magnitudes more nuanced than just a regular old VW engine. Now, unlike most engine blocks, the cylinders aren't built built into the block or the cases on these Porsche engines. They're individual cylinders that bolt to the top of the case. Now that's nice because if you have a failure, theoretically you could just replace one cylinder's worth of rotating components and you'd be on your way. But one of those things that you've got to keep in mind is the distance from the crank center line to the top of the deck is adjustable on the Porsches, and it really should be set with just by precision fits on the parts. So the surface that seals up against the engine case is just a machined surface, and these are typically just held together with glue, and that is what prevents them from leaking oil. And you can put shims under the cylinders to space them up and down if you needed to do that, and I'll explain why you would have to in just a minute. But Porsches typically don't go together with any gaskets. They go together with this anaerobic sealer that goes over the goes in between all the machined surfaces, and that's in the absence of oxygen, it dries up, and that's what seals oil. So check this out. This is where it's going to get a little weird. The height from the distance from the bottom of the cylinder to the sealing surface has to be within 1/1000th of an inch from one another. If you don't set that height properly, you won't seal combustion and or you'll have oil leaks because things are going to get a little goofy. So on top of that, you have a bank of cylinder heads that goes on top of these cylinders. No gaskets. Again, it's literally just a precision fit between the heads and the cylinders. Now, in a traditional cylinder head, you're going to have just a flat machined surface. You're going to encompass every single cylinder unless you're working on maybe a giant-ass diesel. That's going to be individual heads per cylinder again. But most engines, you'll have one cylinder head per bank. Also, don't be this guy. Let the gaskets do the work. That is an excessive amount of copper spray. But you're going to be used to having a head gasket that sits over the top. That'll help make up for some surface quality issues. The parts can be a little bit warped, and it's very forgiving whenever there's a runnability issue. It's not that way on a Porsche. Honestly, it's a miracle and a feat of engineering that these things run as well as they do. That is a lot of pressure to have to hold together with just a precision fit. But by some miracle, and since I'm not that smart, I can't wrap my head around the mechanics of this, they do work, and they've worked very well. These are one of the most reliable German vehicles that you can buy, and there's a lot of them. And most of the Porsches that have been built are still on the road, which is just, again, incredible. Now notice this, there's a step here. There's an outer step and then an inner step. This inner step is what seals up against the cylinder. And the reason why that inner step is so important is because that also plays into the height of the cylinder head. So not only do you have to worry about the height that your cylinders are set at, the height that the heads are set at is very important because it can influence the cam housing that bolts to the top of this. Again, just a precision fit with a little bit of sealer. There's no gasket there. Say you've got these heads at very different heights. So this one's at 0 and maybe this one's at 2,000ths high and this one's at 1,000th high. What's going to happen when you bolt this cam tower down? Let's see here. Got to flip that around. All right. Come on. Drop on. So what'll happen when you bolt this cam tower down, it will twist and warp the cam tower and probably lock up the cam in some cases. And best case scenario is it doesn't lock up the cam. It may just have an oil leak, but it's probably 20 hours to get these things torn down and set back up again. So you want to make sure it's set on assembly and you don't have to worry about it ever again. Porsches, while not complicated engines, there's a lot of nuance and a lot of little things that you need to pay attention to that most engine guys and most engine builders aren't going to really know or recognize unless they had a lot of Porsche experience. And as far as everything else on these engines are concerned, it's really not that complicated, and it's just like any other engine. They just go together in a different way than you're used to seeing. And the only thing that isn't critical about these surfaces is just this outer step. This outer step serves only one purpose. It's to help align things on assembly, but really it's just to create clearance from this surface to that surface. And there's literally an air gap when these things are together. You should be able to see the outside of the head stud if you're looking at the engine from the side. But they're really cool engines. They're air-cooled. They are oil-cooled also, but they run good, they're reliable, and people love them. And there's even several ways that you can resurface the cylinder heads. And you've seen me on this channel resurface regular cylinder heads a million times. This is a lot more interesting, a lot more involved also. One of the things you can do to resurface these is mount them up in a lathe. There's fixtures where you can work off of the top of the head. It bolts up in the in like a regular 3-jaw chuck, and then you get to spin this heavy piece of expensive Germanry and spin it a million miles an hour and recut the inner and outer steps. And the step isn't even anything complicated. You set this diameter, so from here to there, again, that's not even that critical. And then you move up 100 thousandths and then set this step. And again, this surface isn't important, so you can kind of screw that up. But this one, just make sure you get that one surface within 1,000th head to head and you're good. I try to keep them within 0.5 thousandth. Now the way I would do these is I would mount the heads up in a rotary table and I would use an end mill and just do a little pass using an end mill, and that left a really nice surface that I really enjoyed. And I thought that was a really good way of promoting flatness, and it really looked cool, but it was quite time consuming. It probably would take me about 3 hours to resurface a set of heads. Recently, I did buy a new tool that allows me to just set these up once, and then I can just use it as like a boring bar, cut my depth, and then I can move the cutter inward while the machine's running. I'll show you that in just a minute. And then some of the cool guys that have a CNC machine, that's pretty straightforward. They can just write a program and then cut that surface in one circle, move over, and then cut this outer surface, and that's quick and easy. I have that ability too if I go borrow a friend's CNC machine. We'll be doing that on the set of heads we're working on for a different operation. So today we're going to be working on these heads. We're pretty far in the process. A friend of mine called me up. He says, "Hey Josh, I got a problem. This piece of crap engine rolled through. It broke a piston, lifted a head off. It's boosted. It's got a big old turbo hanging off of it. We're going to have to do some things. Maybe you'll have to do a little welding, but check them out. Let me know what we need to do." And oh, did I underestimate how much welding I'd have to do. Originally, there was a groove machined inside of the sealing surface. Now, the purpose of that groove was to house this, which is a flame hoop. You'll see this a lot in domestic race applications that use a lot of boost, a lot of cylinder pressures. Very, very common in the domestic world. And it's starting to be very common in the import world as well. But the Porsche guys have been using these things since the 70s. I think maybe even older than that, but all the Porsche race cars use these things. Their sole purpose was just to give an extra barrier against cylinder leakage or combustion leakage. So the way these work is they would sit inside of a machined receiver groove inside of the cylinder head. These flame hoops are 140 thousandths of an inch thick. Now pretend there's a groove there. It would drop down. 70 thousandths worth of that ring would sit down in the cylinder head groove. And then another 70 thousandths would sit inside of a groove that gets machined into the cylinder. I have to do that still. We're going to do that in the CNC machine off camera. What the original builder did was machine those grooves incorrectly. So instead of half of the ring sitting inside of the head and then half of the ring sitting inside of the cylinder, they were just a little bit too shallow on the groove depth. So the ring was literally holding the cylinder head up off of the cylinder, and it leaked combustion and caused all kinds of issues. A little nerve-wracking. I'm going to have to repair this and recreate that groove and make sure everything's correct this time around. But what that did for me was it meant I had to weld the original machined receiver groove up, and I underestimated how much work that would be. I thought, oh yeah, I'm a gangster with this. I can have these grooves welded up in like an hour. Not a big deal. Then I just have to quickly remachine everything. No harm, no foul. I got this. Well, as it turns out, I was wrong. That operation took me about 3 hours to get everything welded up. I had to do 3 passes stacked on top of one another and just weld up this whole step and start over. That was easier than trying to weld the groove up and maintain the rest of the surfaces. And I'm glad I did actually go that far. Then I had to cut 100 thousandths worth of, let's just call it an 1/8 inch. I had to cut an 1/8 inch worth of weld out, and that got us here. And you can still see a little bit of it. I mean, I wasn't perfect. You can see the edge of the welds right here. And I'll insert a little picture, maybe like right there, of what the heads look like after all the welding. It was kind of intimidating. And they were a little sooty too when I was welding. I used straight helium to get these things welded up, and it welded clean, but on the edges of all the welds there was a bunch of soot, and I wasn't sure what to expect. It actually did keep me up at night, worrying that I'd have to get back in here and start over because I didn't want to keep heat soaking these parts, but it turned out pretty well. And I did track down a welding rod alloy that's very similar to what these heads are cast out of. This is RR350, which is the alloy designation. And that's a Rolls-Royce aerospace alloy that Porsche was using in all of their cylinder heads and a lot of their parts from, I want to say, mid-70s and up. And if you're curious what welding rod it was, it's kind of hard to see, but it's a Hobart product, and it's ER4943. It's a proprietary alloy from Hobart. 10 out of 10, absolutely would buy that again. And I probably won't have to for quite a while because I bought 10 pounds of the stuff. And I've worked on Porsches my whole career, but the 911 stuff, it's kind of new to me. I never really got to spend much time working on these things. And I'm glad that I got to work on them now as opposed to earlier in my career, because I was a very different machinist as far as my skill level was concerned. Literally everything, every new thing I get asked to do is another fixture. Like this fixture, for example, is for setting the cylinder heads up for a second spark plug. Now, if you notice, this head and this head, they're the same casting. They came off the same type of gar. There's 2 spark plugs in this one, and there's only 1 in this one. This is how they came from the factory. This spark plug is aftermarket. That's a very difficult operation. There's only a handful of shops in the entire country that do this and do it very well. One of the most difficult things about that operation is you have to machine a hole that's at 2 different angles. It's rotated and tilted differently than the already existing bolt hole, and it's pointed in such a way where it misses the features inside of the cam tower so that you can actually access that spark plug and do services on the vehicle. So you need to be able to get your socket through these windows to change the lower spark plugs or the new twin plug location. Now, I've done several sets of these with a spark plug location that I came up with. Just the problem is, due to my poor planning, I put the spark plug in a very good location as far as the chamber is concerned, and I was able to get the spark plug in and out no problem with a standard size 13/16 drive socket when the heads were on the bench. But once the cam towers were mocked up and bolted up to the top of the heads, I learned that, oh yeah, hey, I put it in the wrong spot because the socket doesn't fit. And that's no use. That doesn't help. So I spent several weeks designing this spark plug fixture in Fusion using some professional help from my friend Jason. And then we made up this fixture so that it's just a quick and easy operation whenever I need to do a twin plug. Oh, and another thing, Porsche ran with this engine design from like 66 until the late 90s. I want to say that Porsche 911 six cylinders ran from, I don't know, like 65, 66 until like 1995. But as far as the basic engine architecture is concerned, they're all the same base engine design. They all have the engine case, individual cylinders, individual heads, and a cam tower that sits over both banks, and they're all chain driven. There's a timing chain in the front of the engine and a timing chain in the back of the engine. Then they connect to an intermediate shaft in the middle, which then connects to the crankshaft. It's looks scary, and the idea of it sounds scary, but honestly, it's pretty ingenious design. These things evolved from having carburetors to mechanical fuel injection to electronic fuel injection very, very early on. I think these things saw electronic fuel injection as early as the mid to late 70s. And then on top of that, as the engines became updated and more powerful, there would be a few major design revisions that also included bore size increases. And all Porsche did was they just kept moving the bore space outward and outward until, you know, we went from like a 3-inch 600 bore to almost a 4-inch bore, and then in later iterations we got over 4-inch and now your cylinders go well beyond the head bolt holes, and then now the surface of your cylinder head is now, I don't know, an inch total larger across the years. Maybe not exactly an inch in increase of bore size over the years, but I mean, you get the point. It was very, very American of Porsche to just keep increasing the displacement. There's no replacement for displacement, and the Germans knew it. It's very American of them. In fact, the Dukes of Hazzard would have been a very different show if they'd jumped in Porsche 911 instead of an old Mopar. Let's get moved on to the mill, and I'll show you what I've been up to for the past couple days. I had to teach myself how to use a new tool. But I thought I'd get you guys up to speed as far as this 911 rabbit hole is concerned, because, oh man, I have gone deep down that hole. Oh, and I thought I'd like you guys to know that there's been an update with the Porsche Boxster, my car. I just want to make it pretty clear, I'm not incapable of being a bit of a snobby asshole. I was sitting at the bank the other day. The car is running. I'm waiting for the bank to open or something to that effect. And I'm smelling something. I go, whose fucking piece of shit car is on fire? I'm looking around. There's no prime suspects. You know, maybe this work van that's parked next to me, but it was quite a strong smell. A few seconds later, I look at the passenger side window, and I see a wisp of smoke go past the window, and I go, what the fuck? Is it my piece of shit car that's on fire? So then I stick my fat head under the car, and I go, I'm looking through a tiny little space like that, and I go, hey, that oil leak from last year, it hasn't gotten better. And I see a big old spot of oil dripped onto one of the catalytic converters, about that big, and I go, that's a problem. And I get it up on a lift, literally dry engine last year. Oh man, she's wet now. So, update's not catastrophic, but the engine's coming out of the Boxster. And I thought about it. I sat in bed going, while the engine's out, I should put cams in it and do all this stuff. No, I'm going to leave it stock. That's stupid. It was fun to think about for a hot minute, though. And we're going to do an IMS solution and reseal the whole engine, and I'll go back to daily driving the car. But it's mostly drivable. It's just on occasion, it gets a little smoky. Just The smoke is to remind you that there is oil in it. If it doesn't leak any oil, that's because there's none in it. So I haven't talked about this thing a whole lot, but this is a D'Andrea boring and facing head. And it's just like a regular old boring bar. We've seen this boring bar on the channel. It's my only boring bar. It's very small. It's cute next to the new boring head. There's one serious difference between these two style boring heads. This one's basically just a rigid, you set it and forget it type of boring bar. You know, you crank this wheel and it moves this silver portion in or out. And then that's how you set your cutting diameter and go, all right, cool, I've made a hole. This is just strictly for hole making. This one, on the other hand, while you can use it for hole making, it does a hell of a lot more. Now, this boring head isn't bulky just for fun. It's actually got a gear set on the inside of it that changes the direction of this rotational force that the mill creates. So instead of simply cutting in a circle, it will also redirect that spinning energy, and then it powers a gear train in here that moves this cutter in or out. So when I want to move this cutter in and out, all I have to do is I grab this collar while the machine is running, and you see this dial here, it progressively moves this cutter inward. So I've got it set right now to do, per revolution of this wheel, it's going to move inward 5,000. So every time this cutter head makes a rotation, it's going to move in by 5,000ths. If I have it set on the high-speed gear set. This has a 2-speed gear set in here. So if I want it to move half of that amount, I can set this into low gear, and now per revolution of this cutter head, this cutter is going to move in by 2,500ths per revolution. And now the nice thing about this tool is if you're just a strict mill user like me, again, I don't have a lathe, it adds more versatility to my abilities. Before, I was doing a lot of my operations using this boring head. Sometimes you'd have to cut like this chamfer to make clearance for a piston. Porsches often have a giant ass dome in their pistons. So whenever you increase your static compression by a large margin, or you go up in bore size, a lot of times you're going to have to put this chamfer into the cylinder heads. They don't normally come with that. And the chamfer is just to make room for the dome. And if you skip that step, what's going to happen is your pistons will try making babies with your cylinder heads, and that doesn't tend to end with very good results. If you don't know what these things cost, look up what a set of cylinders and pistons cost for a 911. Not only is this boring and facing head super versatile, and it allows me to surface these things really efficiently in the mill, I can reestablish these chamfers or cut these chamfers just with a simple tool change. So yesterday, for example, I cut everything all out. All the welds cleaned up really well. There were a couple little spots that were imperfect, but they're not going to affect anything. Like right here in the corners, I had a little bit of porosity and a couple inclusions. It's pretty easy to avoid next time I have to do this. I know what I'm going to have to do differently as far as my process is concerned, but you know, it's just one of those things. You live and you learn. Live, laugh, love, right? I still had a little bit of weld that needed to be cut out. The original chamfer that was cut into these heads had been disturbed by all the welding, and I had to make up a tool to reestablish this, and I successfully did it, and it came out really beautiful. All it was I had to make a tool change. I've got these simple little tip holders, or tool holders, that will take these tiny little 6mm boring bars. The boring and facing head came with these simple brazed carbide inserts that I was able to grind back to the original angle that the heads were cut at, which was 30 degrees. Now, adding to the versatility of the tool, this is a very, very standard insert. It's CCMX, X being whatever the tool geometry is. So it could be a G, it could be a T, it could be a whatever. I was able to come up with this CCMG insert, which is good It works fine. It left a fine enough finish. It's got this great big corner radius. It's probably a very tough tool for roughing in surfaces, but it didn't cut the weld all that nice. And so naturally, I decided this cutter just wasn't gonna work for me. So I hopped online. I was on the hunt for a PCD tipped insert, and I happened to find one. PCD, or a diamond tipped insert, leaves a very beautiful, shiny, reflective finish on aluminum, and this doesn't have a chip breaker, so it leaves these great big stringers, just like my giant fly cutting head. Moral of the story is, I went a little over the top. I thought, oh, I'm spending all this money on this boring head, I may as well buy some fancy inserts for it. So what we're gonna do today is we're going to finish cutting these cylinder heads. I've already cut 4 out of 6. One of them that you saw on the bench right at the beginning of the video. These ones have been cut, and I've got to cut this guy and then cut that guy. We'll be doing that on camera today. Now this step is currently cut 10 thousandths from final. It's at 90 thousandths in regard to this outer step. So I've got to come down 13 thousandths because I want to recut this outer step. It's a little bit crooked, and then maybe on or off camera, I'm going to flip the part and then cut the cam tower surface referencing off of this outer step. And that's why I'm going to cut this outer step twice. I just want to make sure everything's nice and super square while I have everything set up here. And then when I go to check the thicknesses of the heads, everything's going to be within, I like to keep them within 1/2 thousandth on thickness from one head to another. Really, I can be within 1/1000th plus or minus from one head to another, but I think that could probably create some issues for the assembler, the engine builder, regarding tolerance stacking with the rest of the parts. So I'll draw your attention to the cutter head for just a moment. We'll start it up. I'm not going to cut the part, and we're just going to grab this collar, and I want to show you the function of this. That way you know what to look for. But what's going to happen is I'm going to grab this while the spindle is running. It's not that dangerous. It's not that sketchy. Don't be a And then if you're so lucky, we might even get to see this engine on the dyno sometime in the near future. I'll let you guys know. All right, let's see. I've got this in low gear, so let's move it to the high speed setting. And there we go. See? The dangerous bits are down here. I'm grabbing this. It's really not that much force. If this collar stops, it just slips. It's not as dangerous as you'd think. Now if you see, this whole cutter assembly moved inward as I was holding this collar. And that's generally how these are supposed to work. Now, there's stops that I can set here to set a certain inside diameter or outside diameter of the cut. Right now, I'm only using this stop to set the outside diameter of this bore or this step. And what that will allow me to do is I'm going to spin this cutter the other direction while holding the collar, and then once I hit this stop, it's going to be back to the original diameter. I don't know if you have much experience around tools like this. It generally doesn't work like that, but this is pretty damn stupid proof. And in case you're new to the channel, I need stupid proof. Contact. All right, so we're spinning backwards. So now effectively what that's doing is it's moving this cutter back out to its original position. And then keep an eye on this. Let's look at that cute little hole. As soon as I hit that stop, this collar is going to slip in my hand and we'll be able to start cutting. Should happen pretty soon. There you go. Simple. Not dangerous. Perfect. All right. Let's get to cutting. Now, given my eccentric personality, I would say it's a blessing that I never took up art as a hobby. Because as soon as I try to make a career out of it, I might get a little bitter and start blaming particular groups of people. All right. I would say that is plenty good enough. All right, let's give that a shot. Contact. So what you're going to see first is I'm going to start cutting on the outer ledge. Maybe you won't see it from that angle, but it doesn't matter. So I'm touching off on that step. Just a little bit of WD-40. Just taking my sweet time. I'm going to cut 2/1000 shy of final. I should start touching at the bottom now. Okay. I'm cutting about 0.08 off right now. That went beautifully. This marker's getting everywhere. Whoops. Wipe that off. Made it look a little worse than it actually was. That's a beautiful finish, and that's not even the final pass. The final pass is going to be a 2/1000 depth of cut. I'm spinning the spindle at about 180 RPM. It gets a little goofy when I go to grab the collar, spinning at anything above that. It doesn't seem that the speed is much of a factor here. I'm going to do a 2/1000 depth of cut. The gearbox set at 2.5 thousandths of step over per revolution. And then the corner radius, I didn't speak about the corner radius. This cutter has a 7/1000ths corner radius cut into it. So that means that this surface ends up being very, very fine and very smooth, and you really don't see any lines in the surface. That's one thing that's a pet peeve of mine. I've seen that many, many times when guys do these surfaces in the lathe. They look good in pictures, but when you get the heads up close, you can see these rough step over lines from their finished pass. I don't know that the lathe, while that's how the factory did it, I don't know that the lathe is really the best tool in the world, especially in 2025. Okay, so I've reset the cutter back to the original diameter. Sprayed too much WD-40 on here. That's okay. All right. So we're about to touch off. We're at 0, 1/1000th, and 2/1000ths. if you look carefully, you'll see the cutting action. We're just about to get to the middle of the flat surface. There you go. It's one head down. Look at that. You can see the beads of weld in which direction I was welding. Very cool. Couple little spots of porosity. That little black speck. I think this other thing is a chip. Nope, that's a spot of porosity. One more little spot there. Another little spot there. That's actually, so that spot, I lit up on this. I forgot to turn the gas on. Apparently I didn't grind that out deep enough. Whoops. Happens. It's life. But, very high quality surface. Very happy with how these things are turning out. And in the process of teaching myself how to use this thing, I only crashed it twice, and I didn't even junk any parts. What's the fun in that? Oh, man. All right. Last one. If I was smart, I'd surface every single Porsche that's in the shop right now, but I'm not worried about it. It doesn't take that long to set up a tool. Whoa. Crowded. I'll show you this fixture that we made. You've seen this fixture, I think. All right. That's how I have it held in place, just some studs. The fixture works off of the dowels. Oh, drop my nuts. This fixture is cool. I make these. You've got a nice slot in the middle. This is designed to work with my CP Motorworks head fixture. Both ends or both sides of the fixture are also machined parallel to this slot, and then all these bolt patterns and dowel holes, they are also set up off of these features, these machine features, so I can either indicate here, indicate there, get everything else square in the table. And this plate is made out of cast aluminum. It's a brand name material called Mike 6, and it's used for fixturing. And this is just a precision aluminum plate. Basically, to do anything on a Porsche, you got to have a fixture for whatever the operation is. So as far as doing seat and guide work and now surfacing, this is the fixture that I use, and I just work on 3 at a time, so 1 bank at a time. Now, we've got our last head. Plate's pretty damn clean. I pulled these dowels out, deburred them, got all the extra sealer off the top of the heads. I like using that bolt hole and this bolt hole. But I can use any other hole that exists on the top of the cylinder head to hold the heads down to this fixture. I figured let's have a few choices in case one of these holes is stripped out and you've got to do some work. Just thoughtful, easy. I need to make another one of these because my dowel holes are getting a little worn out. They wouldn't be so worn out if I didn't install seats with the head not bolted into the fixture, but whatever. I can make more. It's just metal, right? Maybe I'll repair this plate. Okay. Drops into place. Everything locates within a thou, even with my worn out dowel holes. And you just sneak the nut down under the plate. The rear stud is just a little bit harder to get to. Can't really see what I'm doing, and some careful finger action to get the nut snugged up, but it's okay. I'm pretty used to it at this point. It's not really that big of a deal. I'm pretty used to this at this point. Quite frankly, I do some of my best work in the dark anyways. Okay, that's snugged up. Finger tight. Okay, let's make a cut. It's pretty damn close. Let's reset the tool. Wouldn't it suck to crash this because I didn't drop the table down enough to clear the tool? Oh, that'd be a story of my life. Okay, let's give this a shot. All right, getting up towards the bottom. We should start touching now. We have. Okay. 2 thousandths away from final. Apologize for the camera mistakes. Whoa. Okay, let's just let this ride. I keep making it worse. I was trying to blow this big old stringer off, but well, there we go. It's just gonna have to go along for the ride. All right. At least I'll be able to show it to you. Yeah, that's the downside to not having a chip breaker on the cutter. Come on, focus. It's time for the final pass. I hope this shot works out. So I don't get a second chance. I have no more heads to cut. I turn down the exposure. Hopefully you can see what's happening in closer detail. I should be getting close to touching. Right about now I should be touching. There we go. One more thou. Perfect. Now let's let it ride. Oh, look at that. I should produce movies. My spindle bearings are not getting any quieter. Neither is the belt drive on my mill. I'm gonna have to fix that soon. There we go. I'd call that a video. Look at that. Nice. That looks good. Beautiful. A few more things left to do to this thing. Somebody got cute with the injector hole trying to make the wrong intake manifold fit, and they got lazy. They took a perfectly good injector slot and turned it into an injector square. I'm not going to have that. So as soon as the intake gets here, I'll mill that off, bore this, and get the porting all blended out. Oh man. Sweet. Well, boys, I think it's time to go. We're going to have a TV party tonight. We've got nothing better to do. We're going to have a couple of brews. Appreciate you staying and letting me share these beautiful Porsches with you. We're still far from done. I've got to cut a valve job and finish out some of the porting. Maybe we'll do a few more videos on this before they leave. So, I'd say that's a good place to put a pin in it. So thank you. Like, comment, subscribe. I appreciate everyone. Leave a comment. Tell me what you want to see next. This is Josh at Engine Rehab. I'll see you next time.